You know that the coordinate system has a horizontal axis called the x-axis and a vertical axis called the y-axis. The point of intersection of both the axes is called the origin. Let's find the coordinates of a point A on the coordinate system. To find the x-coordinate of point A, draw a line from point A parallel to the y-axis until it meets the x-axis, and note down the x-coordinate at the point of intersection. To find the y-coordinate of point A, draw a line from point A parallel to the x-axis until it meets the y-axis, and note down the y-coordinate at the point of intersection. So we can say that the x-coordinate of point A is 20 and its y-coordinate is 15. When specifying the coordinates of a point, its x-coordinate is written first, followed by its y-coordinate. Now, let's use the coordinate system to derive a formula for finding the distance between 2 points whose coordinates are given. A university decides to install a communication network that uses fiber optic cable. Let's say you want to find the length of the cable required to connect the computer department and the mathematics department. How do we do it? Imagine the university campus to be a coordinate plane. Let the point A with coordinates x1, y1 represent the computer department, and the point B with coordinates x2, y2 represent the mathematics department. Now, let's draw a line from point A parallel to the y-axis. This line meets the x-axis at point C. Let's draw another line from point B, parallel to the y-axis. This line meets the x-axis at point D. Similarly, draw a line from point A parallel to the x-axis. This line meets the y-axis at point F. Now, draw another line from point B parallel to the x-axis. This line meets the y-axis at point G. Let point E be the point of intersection of the lines AC and BG. Now, let's join points A and B. We have a right-angled triangle AEB. So we can find the distance between points A and B by applying the Pythagoras theorem, can't we? According to the Pythagoras theorem, AB square is equal to AE square plus EB square. Now, to find the distance AB, let's first find the distances AE and EB. We can say that E is equal to AC minus EC, can't we? Since the coordinates of point A are x1, y1, the distance of point A from the x-axis is the distance AC, which is equal to y1. What do you think is the distance of point E from the x-axis? The length of EC is the same as that of BD, isn't it? Since the coordinates of point B are x2, y2, the distance of point B from the x-axis, that is x-axis, that is BD, is equal to y2. As EC is equal to BD, distance EC is also equal to y2. So, AE is equal to y1 minus y2. Now, let's find the distance EB. We can see that EB is equal to GB minus GE. The distance of point B from the y-axis is x2. So, GB is equal to x2. Do you see that the distances of points A and E from the y-axis are equal to x1? So, GE is equal to x1. And the distance EB will be equal to x2 minus x1. Let's now substitute the values of AE and EB in the equation. We have now found out the distance between the computer department and the mathematics department, and we know exactly how much cable is required to connect the two departments. This equation is called the distance formula. We can rearrange the y-coordinates. As follows to obtain the standard form of the distance formula. Rearranging the y-coordinate will not change the value of distance AB, as we are squaring the difference, and the square of a positive or a negative number will always be positive. The distance formula can be used to calculate the distance between any two points whose coordinates have been provided.